So for the first part of this lesson, we're going to just start with questions 1 to 6 and solve these equations, which we've done before, so you know how to do this. For number 1, this is quadratic, and you know you solve quadratic equations by factoring. So x squared minus 25, every one of you knows that you can factor that into x plus 5, x minus 5 equals 0, right? And then by the zero product property, x plus 5 equals 0, or x minus 5 equals 0. So x is going to be negative 5 or x is 5. And that is a perfectly good way to solve that. But there was another way, and you probably, half of you watching this probably were thinking, why not just do this? Why not add 25 to both sides? Perfectly legitimate. And then we will square root both sides. We call this solving by square rooting. And the one thing we had to remember was to do plus or minus, because we know that there are two solutions. So you would get the same answer, 5 or negative 5, right? So 6 of one, half a dozen of the other. You can use one method or the other. Number 2 is a little bit more difficult, though, because you know that you cannot factor x squared plus 25. So since you can't factor it, let's try to solve it by square rooting. So we'll subtract 25 from both sides, which gives us x squared equals negative 25. And this is where you're going to have a little bit of problem, because we've talked a lot about how when you square a number, doesn't matter if it's positive or a negative number that you're squaring, you're going to get a positive. So this is an impossible situation. You might even try to square root both sides, right? But if you even try that, let's see what your calculator says. So the square root of negative 25, the square root of negative 25, your calculator is telling you non-real answer also. So this is not a real number, right? We can't go there. Cannot go there. So you write that symbol or you write no solution, right? Just can't do it. Number 3, you know what? I'm going to solve that by square rooting, because I know that I can. And the square root of 225 is 15, and we also have to take negative 15, right? So easy. Now, for number 4, I'm going to solve that by square rooting also, but it's not going to work out so nicely, right? So there is some number that I know, in fact, off the top of my head, which when squared gives us 225. I'm not so lucky with 6. I don't know what the square root of 6 is. So this is a perfectly good answer, square root of 6 and negative square root of 6, right? I know it's something. I can do it on my calculator, and I can get pretty close. 2.449489743. But notice how ugly that number is, right? That number is going to go on forever. It's never going to start repeating. That's what's called an irrational number. It's a perfectly good number, but it's kind of hard to represent. Square root of 16, easy. 4 and negative 4, right? That is a rational number. It's nice. This one, if I solve by square rooting x squared is equal to 10, I don't know some number, which when squared gives us 10. So I have perfectly good answers, but I can't give you an exact answer. I can give you an approximation, but that's as far as we can go. So here's what these first 6 problems talk about. Sometimes we get nice numbers. Sometimes that are rational, right? Rational numbers technically are numbers that you could write as the ratio of one integer to another, but they're nice numbers. So it's kind of like Dante's levels of hell, right? Rational numbers are the best, easiest numbers to deal with. More complicated are irrational numbers, right? Irrational numbers are these ones. Irrational numbers are generally numbers involving a square root that we can do nothing with. Okay, they are real numbers. You could plug them into the calculator. You're going to get a complicated number, but these are irrational, right? So the irrationals are red. And then the worst type of number, the worst type of situation is when you're taking the square root of a negative number, right? I can take the square root of 10 and it'll give me an approximation. I don't know where to go with this. That's impossible. So that is an answer that's not even real, right? So these are both real numbers.